Thank you very much, everybody, for coming. Let's start with the cool demo. So this is a piece of paper, and there's the code that draws this cuboid. And I've got a piece of paper, and I can, so long as I move the piece of paper while staring at the cuboid, it looks as though the cuboid has some three-dimensional presence there. And I'll say more about that in a second. Just wanted to say the cool part first. This is a little presentation, perspective experiments, and getting started with Folk Computer. One thing to be aware of is this project Dynamicland, where you've got cameras and projectors in the ceiling. You have an operating system based on that, and Folk Computer is a successor to Dynamicland, which has a public GitHub, which is what I'm running. One reason that you might want a system like this is because projectors are not very confined. You've got lots of meters squared of screen per dollar. In that sense, therefore, projectors are more humane than phones and laptops. It's funny because I was starting to set up my Folk Computer just as I went on my honeymoon, and these are all pictures from my honeymoon. I just noticed that a lot of the places that we were visiting had a huge number of projectors. And of course they do, because projectors allow you to have a public computational thing, just as anybody who's been in a planetarium knows. These are also pictures from Legoland and the Lego house, and they've got these interactive software coming to you from a projector as well. And seeing all of that, I was like, these are beautiful things, but it is terrible that kids cannot make their own software to run on these things. The time is right. It's ridiculous that we don't already have something like Dynamicland and Folk Computer. So moving on, here's my setup. This is Folk Computer running on my desk. I've got a whiteboard that I can scribble on, which I really recommend to anybody. Here's my keyboard, and there's the text editor, and I can write code and make a little program and print it off and so on. Zooming out a bit, there's my whole desk. Up here, I've got a projector, which is the LG Cinebeam, which is extremely annoying to mount, but there's not very many options in the UK where I live. This is my wife doing the mounting for me. The whole thing is held up just up there with carabiners and hairbands. I've got a Linux machine down here, so here's what it looks like when the system boots up. This is an off-the-shelf webcam, off-the-shelf camera stand, an attachment, and down here you've got pencils and pens, which are very important if you're going to be doing this. Here are the Folk Computer people who have made this possible, Andrés and Omar. I've been given a huge amount of help by Mason and Daniel as well. So now to introduce a specific thing I've been researching. These are two interesting problems involving perspective, which I found a hopefully fun solution to. 3D games assume that you are looking directly at the screen. Not necessarily like this. You might be more like this. You've got this assumption that 3D graphics is about putting stuff inside of this volume. But with Dynamicland or Folk Computer, you have a situation like this. You've got this desk in front of you. If you try to render the ordinary way, taking this and just doing that, then that is going to be bad. Here's a picture from Oppenheimer, and if you saw Oppenheimer in the IMAX, then you might have seen this if you were looking at it in the front row. So people sometimes call this the IMAX chin. That's the difference that perspective can make. A related problem, like here's an ordinary operating system. If you take this operating system and you allow this to happen, which it most certainly can happen in Dynamicland and Folk Computer, you can't read these so easily. So that's something to think about. And here comes, you saw it at the beginning, but my elaborated solution to it. This is an experiment in perspective with the Folk Computer system. If I turn over this piece of paper, it's got some code on it that draws this nice cuboid, and I can rotate the cuboid to my heart's content, and it's fairly convincing that there's actually a cuboid hovering there underneath this whiteboard that we've got. It's perspective correct to wherever is 40 centimeters above this piece of paper that we've got here, which is sort of broadcasting its position. And that means that if I move that piece of paper down there, whilst we look at the cuboid, we get a fairly convincing illusion of depth from it, which I think is fun. We can, in principle, fill up our entire screen with perspective correct stuff, like it's a sort of fish tank down there. And that can include text. So I could move that piece of paper around. It draws this text. If I move the other piece of paper around, then it corrects the text to look at me and be sort of perfect from my perspective. And at this point, I really have to credit this inspiration, Johnny Lee's Wii display demo. Yeah, he's got the Wii sensor bar here, and the equivalent of that would be to put the program on my head or something. I don't know if I want to do that. Another option is to make have the camera track my face position. Philosophical point now. So there's a chance that what I've made here goes against the physicality spirit of Dynamicland. So here's Bret Victor, who originated Dynamicland. And here's a quote from him I'll read. What I'm talking about here, this is not VR, this is not AR, it's just R. DR, if you like, dynamic reality. It's real physical matter that you can touch, but real physical matter that offers all the thousands of perceptual cues and physical affordances that we've been honing over the last 100,000 years. And what you saw back there, like, the thing is suspended underneath. The surface of my desk is hard. I can't actually grab that rendered 3D object. But there is a way of saving this. If you imagine that this green thing here, this is the physical object. So currently the green thing is just a piece of paper, but you could imagine it being like a little plastic box, maybe a plastic box with a magnet inside it or something like that. And this red thing, this is a virtual object that you might say is suspended from the green thing, and the green thing can, if you program it right, give you physical insight into what's happening with the red thing. And after all, when you pick up a physical object, like when I hold this pen, I'm only holding this part of the pen. Yes, I can grab that and that, but it's not the end of the world to not be able to touch every single part of a three-dimensional thing. I might be going against the spirit in another sense. So there's a communal aspect. Community is right at the core of what's going on with Dynamicland and Folk Computer. Currently, the system is working for everybody. If we make it so that the system only works from this person's point of view, so this person gets things rendered nicely, but everybody else sees a perspective distorted IMAX chin version of what this person sees. Well, that's bad, but we do have a potential fix for this, which is polarizing or colored lenses. So here we've got two things on my board, and with this pair of glasses, you only see one of those things. In principle, so this is a picture with my wife and I. I have this color, she gets that color. On the board in physical reality, we're looking at two different things, but actually she and I are seeing the same thing. And you might say this is starting to sound a lot like VR. And by the way, I did my PhD on virtual reality stuff, so that's my background. But I claim that we still get lots of advantages that are different from what you have with VR. So with VR, multiplayer is still difficult, whereas this is easier. There's discomfort for your eyes and your neck. With VR, there's no interaction with physical objects, which we can have here. And with VR, you've got this big disconnect between consuming the VR software and developing VR software. Whereas even with this glasses setup, you do still have, my wife and I can both get out our keyboards and start changing what's in front of us without having to take off and put on a VR headset and go from this piece of software inside VR to the text editor. And by the way, projection is one line of code. One line of code, so long as you're using geometric algebra. Geometric algebra is this thing that I'm obsessed with. I've got it tattooed on my arm here, and it's really great for doing 3D graphics. So I really recommend it. Okay, just a bit of an aside there. Now, my use case for Folk Computer Dynamicland stuff is teaching mathematics visually. This is something that I've been into, for all of my career. I've done it in various ways. So here's a bunch of games that I've made that you can play. Well, this one you can't play because I had to take the service down. No one was playing it. But these all teach mathematics visually. I've also done what you might call interactive lectures. These are a bunch that you can play where I'm explaining something kind of like a scientific YouTube video, but then you can also interact with the thing that I'm simulating. And this format, I really, really liked it, but it's not very discoverable. YouTube is a great way for people to see science videos and share them. Whereas with these things, it doesn't have an algorithm recommending things to you automatically, and tweeting it doesn't, incentives. What are you going to do? So I've kind of moved away from these to other things. I've been working on coding tools for 3D. So this is a YouTube video I made where I had this coding tool, which you can go to a certain website and use it yourself to some extent. I also made this virtual reality program where you're kind of coding visually in virtual reality, but I didn't. I wanted to take this further, but I needed investment for it, and I didn't really get that. So that was unfortunate. There's at least a video out there where you've got a proof of concept for it. What I've ended up doing instead is YouTube videos where I am interacting with a simulation, and you can see the simulation that I'm interacting with. This 3D one here, I've got this huge helmet on because underneath there I'm wearing a virtual reality headset, so you can't see my actual eyes, you have to see these virtual eyes. And it doesn't work half bad. This was a proof of concept for this. This is a version of this where the camera is being moved around, but it's a bit horrible to align things. But yeah, 3 Blue 1 Brown is doing this to some extent as well, not with virtual reality, that is, but with both of these videos, you see me interacting in real time with a simulation that I've previously made, and that's how I explain the science to you. Recently, I've gotten very into teaching maths with physical toys, which is a good fit for Folk Computer and Dynamicland. There's a proud tradition of this. Martin Gardner and Vi Hart do it a lot. Tadashi Takeda, you can hear him sing the praises of teaching mathematics with physical toys. Here's some examples of me doing that. Lego and climbing frames, and my wedding ring here actually has a hyperbolic paraboloid reflection on it, which I can do a fun magic trick with. And I want to use the Folk Computer system for this. I want to make a YouTube video where I'm interacting with the simulation in real time. Maybe people get to see me coding the thing as well, and I have some physical objects as well, and I have some virtual objects as well. But the recording setup is a open problem that I wanted to discuss with you folks. This is a setup that some people have for YouTube videos today. So this is Steve Brunton. He's got some great videos, and you get to see him just like with an ordinary blackboard, except he doesn't have to turn his back to you. He draws pictures, he does equations. It's all good. I want to have both of those things. There's a puzzle here, so I want to have a setup that ends up looking, you get a YouTube video out of it that looks like this. And I've got this physical object or this virtual object in front of me. My projector is up here. There's a virtual object in some sense suspended below me there. I could put the camera, say, here. I could put it here as well, but that kind of, and that makes it so that the virtual object, it doesn't get to be, it's able to be further up than with this one. I could put it here, but that makes it so that you've got upside down writing. So you can see my writing down here, but yeah, it's upside down, which is no good. I could put the camera down here, but that requires a transparent board, and I'm not sure how to project onto it. And I could put it here, but that requires that the virtual object be up here, which is going to be uncomfortable. Not uncomfortable, but strange for me, because it's nicest when the virtual object is beneath this surface in front of me. Projecting on a transparent tabletop, maybe something with a half silvered mirror or something like this, and maybe having this in darkness down here. And anyway, that's the end of the presentation. Thank you all very much for joining me for that.